Hi guys, I would like in this video demonstrate you the benefits of a back EMF circuit. I'm not claiming over unity this time. The idea is to send 12 volts here from the beginning to a simple coil right here to create lots of back EMF with the use of a simple square wave generator who can provide us pulses from 0 to 99.9% duty cycle. I will show you later the circuit. The high voltage impulses are charging a high voltage capacitors of 470 nanofarad 1000 volt right here, and with this power I'm lighting the incandescent bulbs behind right here as a load. This circuit has the same function of a boost converter, but a little bit different in this construction. The results are fascinating. Okay, this is the circuit diagram of the square wave generator who drives the Mosfet here, the IRFP 2907. Through this switch here, you may change the output of the square wave from 0 to 50% or 50 to 99.9% duty cycle. In this case, I'm going to use the second choice. Right here is what I mean. This coil is a 10-meter normal 2mm cable and serves as an inductor, stores energy in form of a magnetic film which is around the coil, right here, around the coil. When a current passes through, when the power is on, the electrons in the current create a strong magnetic field around the coil as they move through it. Back EMF always approaches the charge that created by turning on the circuit. The results, as you know, can efficiently divide the current away from the inductor towards the capacitors, right here, and all this energy can be tapped in it extremely fast. In this case, we have a high voltage measured about 200 volts. This high voltage impulse created from it has always a positive value from the negative side right here of the Mosfet. That's why I used ultra-fast diodes here and here to block the return backwards and make distraction to the other circuit. It generates pure EMF. Alright, this is the whole setup. The square wave generator, as I described you before. The stabilization, the voltage stabilization according to the circuit diagram. The Mosfet on a heatsink. The coil, 10 meters of 2mm double cable. As you see here, I'm using only one. The capacitor, 0.47 microfarad 1000 volt. And the bulbs. This is a bulb from a microwave oven. It's about 10 watts. Another one 100 watts on 200 watts as a load. In order to understand what is happened when the device is on, I put the yellow probe of my oscilloscope on the coil right here. This one, just on the coil. And the other one, also the red one right here, at the input of the pulses to the Mosfet, right out of the generator. I'm turning on, and you see right now the bulb is on. The bulb is on. We consume 4.73 amps at 12.7 volts. I'm turning on the 100 watt lamp together with the other one. 4.48 amps. The 200 watt, only 4 amps. Now let's check the oscilloscope. The yellow impulses here is the back EMF. The input of the Mosfet, 81.7% duty cycle, 44.39 kilohertz, the frequency. Also the power of the bulbs and the consume. Now in this configuration I changed the connection of the coil to a bifilar coil, a Nikola Tesla bifilar coil. I slightly adjusted the frequency and the duty cycle and see what is happening. Only this bulb is on. Right here is we have the same impulse. Duty cycle is 84%, about. The frequency 22.41 kilohertz. The consume is only 0.66 amps. Now I'm turning on the first bulb, the 100 bulb. It's 2 amps, and with the 200 bulb we have about the same, 4 amps. The same configuration with a bifilar coil. And the impulse, the same. For all this who would like to replicate this project, have to pay attention at these impulses. These impulses are the key to the great efficiency. At the output, they are very, very sharp, as you see. At the drive of the duty cycle. If I try to minimize the duty cycle, look what is going to be happening. Right here. Right now I minimize the duty cycle. Other side. Right there is 79% and the efficiency is not good, but if I maximize a little bit, right there. This is the maximum consume of it. 5.43 amps. I am now planning other projects with higher efficiency, and I'm going to demonstrate you, of course, all the results. See you in the future. Thanks for watching.